know, electron beam processes, they're quite well known in the welding industry, for example. But what about metal additive manufacturing? I'm with Oscar Angerveld. He's product manager for Spectra H for Arcam EBM. Oscar, we're standing next to a machine which has some pretty unique capabilities. Tell me about it.
This is the Spectra H machine, and it's an EBM machine. It's used within the metal additive manufacturing. An EBM machine has a vacuum inside it, so we can operate with our electron beam.
Now you're talking about materials that you can't normally print by conventional. So they show about luminides here. These are like cements. We're talking about materials that are very, very high melting temperatures. What kind of temperatures are we talking about?
About 1,000 degrees Celsius.
And this can be printed in a similar way that we print conventional metal alloys?
Yes. Okay.
And with electron beam?
Electron beam.
Tell me, how is this differ from, say, typical, say, laser-centered processes?
The electron beam technology is that we print under an elevated temperature, so the build is at 1,000 degrees all the time, so we don't get any cracks during the build. We manage the beam by having a vacuum where we melt the parts.
Yes. So the entire unit is a vacuum chamber, and everything happens inside?
The build tank is inside the vacuum chamber.
Yes. Now, electron beams, historically, this is focusing electron beam, of course, it's electromagnetic processes. We think of the old days of television originally, we were focusing electron.
Yeah.
How is it done these days? Is electromagnetic process a focusing process to make this work?
Yes, we have coils that control the beam, so you adjust the beam size,
yes,
astigmatism, focus.
Yes, magnetically or electrostatically?
Magnetically.
Yes, okay, so it's rather like the television picture tube notion? Okay, except much higher powers, presumably.
Yeah, it is. Yeah. We have 6 kilowatts in this beam.
6 kilowatts?
Yes.
Okay, so this is equivalent to a high-powered laser in terms of...
Yeah, I think we are market leading with 6 kilowatts.
Yes, considerable power. And is electron beam compared to laser? The laser, we just simply think of putting heat into a spot.
Yeah.
Is this the same concept here? Is this really just about putting heat into a spot, or is there something more complex?
We want the complete powder bed where we melt to be warm, to have an elevated temperature.
Yes. So the powder is raised to, so the incremental additional temperature rise?
Yes, we sinter the powder around the part. Yes. Which also enable us to actually stack parts on top of each other. We don't need to anchor the printed part in a start plate. We can start to print straight out of the powder.
Really? With no supporting structure underneath?
Not directed or in contact with the start plate, no.
Yes. Are there circumstances where specifically you would recommend electron beam over, for example, laser?
For crack-prone materials, you need to have an elevated temperature when you melt them.
Okay, and crack-prone materials meaning the thermally cycle?
Yes, if you cool down too quickly, they will crack.
Okay, so how does the cycle time compare to other technologies?
Now we have a pump time, since we are under vacuum.
Yes.
But the benefits is that it's a clean environment, so if for some reason you get a pour, it's nothing inside, it's vacuum, so you can hip it and you close it completely. When you print the part, as I said before, we keep the temperature at a certain increased level all the time. And the complete build is actually hot when we are done with the build, so it needs to cool down.
Okay. Now you mentioned titanium aluminide, a very exotic material by most people's standards. Are materials readily available through Arcam? Are they bought from outside sources typically? How does the customer usually source the raw material?
We offer powder, titanium aluminide powder to our customers.
So typically your customers buy the machine and also a contract to supply the powders?
Yes, they can.
Okay. Oscar Angerveld, product manager for the Spectra H at Arcam EBM, says, think about electron beam technology if you need a material that has very, very high temperature and crack resistance.